All right, welcome to our first lesson for Chapter 9. Chapter 9 is all about non-renewable energy sources. So we'll talk about what that is in this lesson. This first lesson is just going to focus on like an introduction to non-renewable energy sources. So learning objective or learning goal is that you will be able to describe how fossil fuels are formed. So non-renewable energy sources are those whose resources are being used faster than they could be replenished. So that just means like we're using them faster than they can grow back. So like oil, coal, natural gas, those things take hundreds of thousands, sometimes millions of years to form. So we're definitely using those things faster than they can form because we're using them pretty quickly. So the examples are coal, oil, and natural gas. But these forms of energy sources currently provide 80% of the world's energy use. So even though they're non-renewable, even though we don't have them forever, currently they make up 80% of how we get our energy. Renewable energy sources replenish themselves, or they're continuously present as a feature of the environment. So an example of them replenishing themselves would be like biomass, like trees grow back. As long as we're not constantly clear cutting a forest, if we're taking a tree here or there, theoretically there should be, if we're using it sustainably, there should be enough time for another tree to grow back and kind of replace the trees that we're cutting down. For something being continuously present as a feature of the environment, solar power, the sun is always there. It's less there when it's cloudy, but sun's always out there. Wind power, hydropower, all of those, water, wind, solar, those things are always going to be there. So they're continuously present as a feature of the environment. They're not really replenishing themselves. So our examples are solar, geothermal, tidal, and etc. We will talk about all of these in Chapter 10. Renewable energy sources currently provide about 12% of the energy used worldwide, primarily from hydroelectricity, which comes from dams, and firewood, which is an example of biomass. All right. One thing we need to talk about when we are talking about these non-renewable energies and how much of them that we have is what a resource is versus a reserve. So a resource is a naturally occurring substance of use to humans that can potentially be extracted. So it's something that exists that we could use that maybe somehow we could get to. It exists. A reserve is a known deposit. We know where it is that can be economically extracted using current technology and under certain economic conditions. We know where it is, we know how to get it, and we can afford to get it. That's a reserve. A reserve is what we can actually get and use. So if we look at this graphic over here, this whole square, that whole thing is resources. And as we go higher up in the square, that means we're going from least known down here. It's undiscovered, but like we think it maybe exists. We know a little bit. We don't know a whole lot about it. And as we go up into this top half, we know about it. So these, the top half is identified deposits. We know exactly where these are. And then from left, that's least economic, to right, highly profitable, we know where this square is, this square of oil, coal, whatever. We know where it is. It does not make financial sense to harvest it because it would cost so much money to harvest. And so our reserve is where those two kind of meet. We know about it and it's highly profitable. Someone can make money off of getting that. So reserves are smaller than resources because resources is like the whole chunk and reserves are just the chunk that we can actually get to and that we can afford to get to. Reserve levels change as technology advances, as new discoveries are made, and economic conditions vary. So this reserve is profitable right now. If there's a crash or there is a pandemic that if it's oil, people aren't using cars anymore or using gas nearly as much, maybe some of this reserve is not economic to extract anymore. If there's a new oil drill technology that comes out, maybe more of this is economic to drill. So that can change based off of those factors. All right, let's talk about fossil fuel formation. So how we actually get the fossil fuels we are using. So let's start off with coal. So 300 million years ago, there were vast expanses of freshwater swamps. When plants died, they accumulated underwater, forming a spongy mass of organic material. And then due to geologic changes, some of these deposits were covered by seas and covered with sediment. So this was aquatic succession. So over time, sediment came in or more water came in, then more sediment came in. Oops. And then the pressure from sediment and heat over time transform the organic matter into coal. And depending on how long or how much moisture there is, that determines what kind of coal it is. So there's different kinds. So there's 5 different kinds specifically. So there's peat, lignite, subbituminous, bituminous, and anthracite. And all of those, so we go from peat first is like the least compressed, a lot of moisture, not a lot of carbon or volatile compounds. So that doesn't have a ton of energy in it. And then as time goes on and more pressure, we get all the way to anthracite, which is fairly rare. Then if we look at the world coal reserves, so the Asia and Pacific has the most, then Europe and Eurasia, and then North America. Africa, South and Central America, and the Middle East have very little. There was not a whole lot of swamps that existed 300 million years ago here, so they did not end up with a lot of coal. All right, for oil and natural gas form together, and they most likely originated from microscopic marine organisms that accumulated on the ocean floor and were covered by sediments. They are not from dinosaurs, I'm so sorry, unless you count like really, really old zooplankton and phytoplankton, the little microscopic marine organisms, as dinosaurs. But those little organisms died, settled at the bottom, and then they were covered with more sediments, and then more and more and more. And as the organisms broke down, they released oil droplets into the sediment. And muddy rock gradually formed shale, which contained dispersed oil. So normally oil would kind of like filter up and float through the water, but this muddy rock kind of formed a seal on top of that so that those oil particles couldn't escape. And then geologic changes caused migration of oil into porous rock. So here's an oil well. It's going all the way down. Here's the shale, like where the rock that it can't get through. Here's natural gas. Here's oil. Beneath the oil is typically water. And these are permeable rocks. Permeable means you can get through it. So there's kind of air spaces in between or spaces in between that the gas, oil, and water can fill up. So remember, as reserves versus resource, there is always, a certain amount of oil that is that exists as a resource, but reserves are going to most likely increase because our technology has increased, so it's cheaper to harvest. So the proved oil reserves increases as new deposits are discovered, and new technologies allow oil to be extracted that was not possible previously. All right, in the next view, we will talk about the dangers with fossil fuels. One lesson specifically on carbon, and then the other one on oil and natural gas. If you have any questions, please let me know.